Good day and welcome to physics class. Today we shall be looking at another topic, which is dimension. Dimension is another important topic in physics. Now, when you say dimension of physical quantity, you are actually saying the power to which the basic units of mass, length, and time must be raised to describe that quantity. Also, dimension shows the physical nature of physical quantities. If a physical quantity is measured in the unit of length, we say that physical quantity has a dimension length denoted by capital letter L. If it is measured in units of mass, it has a dimension of mass denoted by capital letter M. And if it is measured in units of time, it has a dimension of time denoted by capital letter T. So we say dimension of physical quantity is the power to which the basic units of mass, length, and time must be raised to describe that quantity. So, in essence, dimension shows the physical nature of physical quantities. Alright, so we can see that from all what we have here, it means that the dimension of physical quantities actually describes such physical quantities in terms of the three basic fundamental quantities, which are mass, length, and time. So the dimension of mass, length, and time are denoted with capital letter M in closing brackets, L, and T. Okay, so take notes. Alright, so from here, you will also observe that since we are expressing the dimension of physical quantity in terms of the three basic fundamental quantities, it tells us that if we want to look for dimension, we're actually looking for the dimension of derived quantities. So dimensions are actually used to describe derived quantities. Please take note of that. Very, very important. Okay, so let's look at the dimensions of some physical quantities. Dimensions of some physical quantities. Dimensions of some physical quantities. So let us begin. So let's look at force. For force is mass times acceleration. So to get the dimension of force, so will be the dimension of mass, which is m. You can enclose in a bracket. You can choose not to enclose in a bracket. It's also upsetting. The dimension of acceleration is L. Okay, pardon, let me do something so that we understand what we are trying to do instead of just going straight to the dimension. Because already we know the dimension of mass, which is capital letter M, but we do not know the dimension of acceleration. So we can go further, saying the formula force is mass times acceleration is velocity over time. Alright, so this gives us dimension of mass is capital letter M, dimension of velocity. So for you to do this, you can use the units of the physical quantities to get the dimension. So the unit of velocity is meter per second. It's meters per second. Now, which physical quantity has the unit as meter is length? So meter, so we have the dimension length. So which of the physical quantity has the unit as time, as second is time? So this is t to power minus 1. Of course, dimension of time is t. So this is equal to, now this is power 1. If this goes up, this t to power 1 becomes minus 1. So we have mlt to power minus 1 times t to power minus 1. So this is equal to ml. I have t here, so I can add the powers. Minus 1 minus 1 gives me minus 2. So this is t to power minus 2. So let's look at power. Power is, okay, let's look at work first. Work is force times displacement. Now dimension of force mlt to power minus 2. Displacement is in form of length. So dimension of displacement is same as dimension of length. So we have L here. So So this, because since I have L here, L, so L times L gives me L squared, or you add the power here is 1, the power here is 1. So according to the law of indices, so you can add the power since they are multiplying. So 1 plus 1 gives me 2. So I have M L squared to the power minus 2. So I can take another one here. Power. Power is work over time. So the dimension for power will be the dimension of work over the dimension of time. So dimension of work here is ml square t to power minus 2. So I have m l square c to power minus 2. Time is t. So this gives me m l t to power minus 2 times, the power here is 1. If I take t up, t to power 1 up, the power of t becomes minus 1. Minus 1. So this gives me ml minus 2 minus 1, since this is t, it's minus 3. Now you can go back to our previous lesson where we discussed derived quantities and their units. You find out that the unit of power is same. Sorry, it's not the same. So from the units of power, you can obtain the dimension of power. You can check that for yourself. 4. Pressure. Pressure, force over area. So the dimension of pressure will be the dimension of force over the dimension of area. Dimension of force is m l t or minus 2. Dimension of area is L square. Area is length times breadth, so this will give me length times length. So this is equal to m l t to power minus 2 L times L. So I can take one of these out, so I have just L here, since I cancel one of this. So this gives me, the power of L here is 1, so if I take it up, it becomes minus 1. I have ml to the power of minus 1 t to the power of minus 2. Again, go back, look at the derived units of pressure. From there you can obtain the dimension of pressure. So let's take one more. Surface tension. Surface tension is force over length. So the dimension becomes dimension of force m l c to power minus 2 over dimension of length L. So we'll take care of this. So this becomes m t to power minus 2. So with this, I believe you understood what we've done and how we arrive at the dimensions of each of these physical quantities. So just follow the procedure so you can obtain the dimensions of other physical quantities. Okay. Now, you can use dimension to check the correctness of the formula of an equation. So in other words, you can check if an equation is dimensionally correct. For example, if we have this, if we have V equal to U plus AT, we can check if this equation is correct by using dimension. In other words, we can check for the dimensionally correctness of this equation. So what you need to do is, so you check the dimension of each of these terms. So let's begin from the left hand side. So from the left hand side, we have V. What is the dimension of velocity? We know that the unit of velocity is the meter per second. So from here we can get the dimension. Now the physical quantity that has the unit as meter is length. So I have L. The physical quantity that has unit as second is time. I have LT to power minus 1. So I'm done with this. So go to the right hand side. So I have U, the same thing as velocity, but it's the initial velocity. So this will still be LT to power minus 1. So I have A times T, which is the term here. Now the dimension of acceleration, we did that earlier, is LT to power minus 2 times time times T. So this is power 1 here. Remember, this is power 1. So minus 2 plus 1 will give me what? Minus 1. So I have LT to power minus 1. So you can see that each of the terms was correct. So we say the equation is dimensionally correct. The equation is dimensionally correct. Let's look at another equation. Let's look at this. The period of a simple pendulum T to 2 pi roots L over G. Here T is a period, L is the length of the string, G is the acceleration due to gravity at that point, which you can also call as what? The local acceleration due to gravity. So again, we check term by term. However, we're not concerned with this constant term here because it is a number, it's a value. So what we're concerned is what? Is the physical parameters, which is T, the period, L, and G. So the left hand side, the period is the same thing as time. So the dimension of T is still equal to T. This is dimension, why this is the physical parameter, which is the period, which is the time taken to complete one oscillation. Then right hand side, we have root L over G. So this is the same thing as, from your indices, record that if you have this A to power half is the same thing as root A. Alright, so if you go back and forth, so if the power is half, you have root A. So if you have root A, the power becomes half. So this is the same approach here. This is L over G to power 1 over 2. So this is equal to, so again, from your power law, if you have A, So these powers can multiply each other. This will be a to power m times n, which is mn. So it also applies to what? So the power outside we multiply the power inside. So what is the power here? 1. The power here is 1. So I have L to the power 1 over 2 G. Is for the sake of this, you know this divided by G to the power 1 over 2. Now, what is the dimension of length? Is capital letter L. So this is L to the power minus raised to the power 1 over 2. G is acceleration. What is the dimension of acceleration? L c to the power minus 2. Remember, there is a power here which is half. So this is equal to L to the power 1 over 2 divided by the power outside will multiply the powers inside. So what is the power of L here? Is 1. 1 times 1 over 2 is 1 over 2. So I have L to the power 1 over 2. So I also have minus 2 times 1 over 2. So this will take care of this. So this becomes L to the power 1 over 2. So I can use over now. This is L to the power 1 over 2. This is minus 1 c to the power minus 1. So this will take care of this. At the end, I have 1 over c to the power minus 1. Now again, in indices, if you have a to the power minus m, which is a negative index law or negative power law, it becomes 1 over a to the power m. Now, so I will use same approach here. So I have 1 over t to the power minus 1. Since this is minus 1, if I take it up, this minus 1 becomes plus 1. Then we have t to the power 1. So you can see the left hand side is t, the right hand side is also equal to t. So this equation is dimensionally correct. So we have seen how you can use dimension to check the correctness of a physical equation. So again, I will implore you to look at it and know how we arrive at the dimensions of each of the physical parameter, and also you practice more problems. If you have any question, you can drop it. We'll gladly attend to your question. So for now, we call it a class. In subsequent videos, we'll treat questions from a past question paper. The question will cover what you've been taught earlier, which are motion, fundamental and derived quantities, as well as dimension. So do have a great day. Bye.